Hi, welcome. I'm Tom Greenbaum. I'm Data Center Operations Manager for one of the highest density computer centers in the world. What's interesting about this particular data center is that it also is a retrofit fab. As you can see, the lockers are left over from the old days when this building used to produce silicon chips. So we're going to show you some innovation on this tour, and the innovations will be around power delivery and air cooling. We had a cost avoidance of several millions of dollars by reusing an old factory which could not be used to go to the next generation chip manufacturing. So instead of building a brand new data center, decided we had resources available which would support a state-of-the-art data center. First stop on the tour, conventional data center, one of the first major IT data centers built on site. It has a conventional raised floor with computer room air conditioning, but it also has fully redundant mechanical and electrical systems which support mission-critical applications. These applications can only withstand one scheduled downtime in a 3-year period. Conventional computer room air conditioning unit, which supplies cold air through the raised floor. This is very traditional in modern data centers. We have here cold aisles and hot aisles. For our second stop on the tour, we're going to see an exciting room. Innovations in air cooling, 6 megawatts total IT power, 4,700 high-density blade servers. The challenges to retrofit an existing factory building were definitely an inspiration to innovate. We innovated in several ways. We didn't use a raised floor. We used the existing concrete slab. This enabled us to put high-density racks on this floor. Here we're running high-performance computing, 14 blade center chassis. These are some of the highest density racks in Intel, 2,000 pounds per rack, 30 kilowatts per rack. The room is pressurized with cold air. All the hot air goes up the chimney. By putting a chimney on the back of the rack and then cleaning up the airflow obstructions in the rack, so you're not relying on those little fans in the cabinet anymore, but you're relying on the big air handling units that you have to move that air through. And all that is going directly through those racks in a very controlled fashion, and that's because of the chimney rack. We've built flexibility into the new plans for the data center. We have a phased approach, and we did it in such a way that in each phase we provide the most flexibility and agility to land a variety of requests from our customers. Phase 2, we add additional capacity for 10,000 more servers. This supports our long-range plan of data center consolidation. We have power in place to support all this plug and play. Roll the rack in, plug in the power, plug in the network, you're good to go. This is an old factory loading dock that we converted to a battery backup room, providing 10 minutes of continuous power in case of a power outage. Next room is our UPS room, which controls all these batteries. 6 megawatts of IT power to our data center. We're on the 3rd floor of the factory building that we retrofit for our computer room. This is also called the interstitial space, where we have all the air handling units. As you can see, we added capacity by putting another chilled water coil on the back of these existing air handling units to meet our capacity needs for cooling. We also gained valuable floor space in the computer room by not having to put computer room air conditioning. So we use the factory to our advantage. You can hear the noise behind us as we get closer to one of the world's fastest supercomputers, 14,336 Xeon cores. Right there underneath the supercomputer we had process chilled water, which was used in the factory process. And we were able to feed that right up into the supercomputer chilled water cooling jackets, which are on the back of the supercomputer racks. You know, there was a lot of resources, there was a lot of capabilities, power, reliability, the mechanical equipment, the load-bearing floor. So we discovered that by applying some good engineering, some innovation, we can make it work, and we can make it highly successful.